So this is the lecture for section 3.1, MEC 1105, College Algebra. So in this section, we're going to be talking about the composite functions. So if f and g are functions, then the sum of the two functions is defined simply as f plus g of x, which is just f of x plus g of x. Now the domain of that function is just the intersection of the domain of f and the domain of g. Same thing with the difference. So f minus g of x is just f of x minus g of x. Again, the domain is just the intersection of the domain of both functions. So just be aware that when we combine two functions, we can, in essence, end up with a, oops, sorry about that. Let me close that. So when we combine two functions, we, in essence, can end up with a new function, right? So f of x plus or minus g of x ends up with a function, it could be h of x. The product, f times g of x, is just f of x times g of x. Now the quotient of f divided by g of x is simply the ratio of f of x divided by g of x. Now the domain of this is at all values of x such that g of x is not equal to 0, and then also the intersection of the domain of f and the intersection with the domain of g. So the added with the quotient is just that we have to exclude the values that would make g of x equal to 0. So for the first one here, we're going to state the domain and the range for each of the given functions. And so we're going to see if each relation is a function. And so the domain for this particular function would be the values 1, 2, 3, and 4. Now the range would just be 3. Now I don't have to repeat it every single time, simply because it's just an element in the set. It's like putting something in a bag, if you will. So I don't have to put it 4 times. So the range is just 3, and the domain would be the values 1, 2, 3, and 4. And this is a function. And it's a function because the domain values do not repeat. So for each unique domain value, there's there's just one range value, if you will. So for number 28, the domain would be -4, -3, -2, -1. Again, since -4 appears twice, I don't have to write it both times. And then the domain would just be 4, 3, 2, 1, and then 0. Now, this is not a function. And it's not a function because I have -4, 0, but I also have -4, 4. So the value for the domain -4 actually has two individual values that maps into two distinct values, 0 and 4. So this is not a function. So the next one says determine if the equation defines y as a function of x. Now, we can go ahead and graph this, but if we look at the graph of this, so let's just go ahead and think about that. It's going to look like something like this, right? So it's going to look similar to this. Now, the way that we determine whether it's a function, we'll talk about it, I believe, in the next section a little bit more, is the vertical line test. So you can see that if I were to draw a vertical line all the way from the values of x, possible values of x, it only intersects the graph at one point at a time, right? So it crosses it here, and every time I do it will just be once. So then this is a function, so it does define y as a function of x. Now for number 34, again, if I were to look at the graph, and this is just a rough sketch of the graph, right? But it'll be similar to this. So then this one, the way it looks like is going to be something like this, right? And so again, if I were to draw a vertical line each time, you can see that it only crosses the graph of the function at one point in time. So then again, this is a function. And this also is a function. Now for number 43 and the rest of these, we're we're going to find the following values. We're going to find f of 0, f of 1, f of negative 1, f of negative x, and so on. So I'm not going to do all of them just for the sake of space. So I'm going to go ahead and do f of 0. So f of 0 just means that I'm going to replace the variable with the value that they give me. And then for this one, it's going to be f of 0 is equal to negative 4. So when x is equal to 0, the value of y is equal to 4. The value of f of x is equal to 4. So the way that we would write that would be x f of x, which is simply x and y. So remember, y is equal to f of x, right? And so for this case would be 0, negative 4. So I'm going to go ahead and do negative 1. So this is 3 times negative 1 to the second power plus 2 times negative 1 minus 4. So negative 1 to the second power is 1. 3 times 1 is 3. 2 times negative 1 is negative 2 minus 4. So here 3 minus 2 is 1. 1 minus 4 is equal to negative 3. Now the next one that we're going to have, and I'm going to do negative f of x, which simply means that I'm going to multiply the function f of x by negative 1, which is going to give me negative 3x squared minus 2x plus 4. So basically I'm just going to go ahead and distribute that negative. Next one I'm going to do is I'm going to do x plus 1. So it's going to be 3 times x plus 1 to the second power plus 2 times x plus 1 minus 4. So then this is going to be x squared plus 2x plus 1 plus 2x plus 2 minus 4. So you can see that I'm just sort of just distribute the 2 here in the 2 times x plus 1. And then, of course, x plus 1 to the second power. If I FOIL it, I get x squared plus 2x plus 1. And then I go ahead and distribute the 3. And so the next step would be to combine like terms. So I'm going to write it in descending order. So 6x plus 2x is 8x. Now 3 plus 2 is 5. Minus 4 is equal to 1. So that's f of x plus 1. The next one that I'm going to do is I'm just going to do f of 2x just for the sake of space. So it's going to be 3 times 2x to the second power, 2 times 2x minus 4. So 2x to the second power is just 4x squared. And this is going to be 4x minus 4. And so again, here I'm just going to have 12x squared plus 4x minus 4. And that's how you do that one. Now, for number 46, so I'm going to leave 48 for you for extra credit here. And so for 46, I'm going to go ahead and do f of x plus h. I'll go ahead and do some more, but I'm going to do this one. So x plus h squared minus 1, and then x plus h plus 4. So then what's going to happen here, that x plus h to the second power ends up being x squared plus 2xh plus h squared minus 1 all over x plus h plus 4. And so we can't really combine any like terms, either the numerator or the denominator, so we're going to leave that as is. So here, if I go ahead and do f of 0, I got 0 squared minus 1, 0 plus 4, which is going to be negative 1/4, right? And then the last one I'm going to do is I'm going to go ahead and do f of negative x. It's going to be negative x squared minus 1, and then negative x plus 4, which is just going to be x squared minus 1, and then negative x plus 4. So just remember here real quick that negative x to the second power is equal to x to the second power. Now, if I don't put it in parentheses, then that is not the same as x squared. So you're going to, so for this one here on the left side, you're going to square the x and then multiply by negative 1. So it's going to be negative. All right, so number 58 and 53, 59, we're going to go ahead and find the domain. Now, 52 is a polynomial, which means that if I were to graph it, I would not lift my pencil off the paper. So it'd be a continuous line with no holes, no gaps, or anything like that. So then therefore, here is that x is a real number. And so you might see it written this way. So in other words, I can plug in any real number for x and I will get back a real number. If I was to write it in interval notation, it'd just be negative infinity to infinity. Number 53 is a rational expression. Oops, let me rewrite that here real quick. And so we're going to look at the denominator. We're going to set the denominator equal to 0. So what we're trying to find out is, where is the denominator equal to 0? Because if it's equal to 0, it would be undefined since we cannot divide by 0. Now, what happens here is that if I take the square root of both sides, notice that I have the square root of -1. Now, square root of a negative value is not a real number. So in other words, x squared plus 1 will never be 0, and so therefore the domain is all real numbers, negative infinity to infinity. Now, 59 is a radical equation, so then function, sorry. So what we're going to do is we've got to make sure that the radicand here is greater than or equal to 0. So it can be 0 because the square root of 0 is just 0, which is a real number. But if we get a value that makes it negative, then that can't be, right? Because then that would be, it wouldn't be a real number. So then we set the radicand greater than or equal to 0. We're going to solve this, right? And so the values, all the values of x that are greater than or equal to 4 will make this a real number. So if you think about this, right? If I plug in 4, I'm going to get basically square root of 0, which is just 0. And that's okay because 0 is a real number. So then the domain of this would be all numbers x such that x is greater than or equal to 4. And that's how you do number 59. Now, for number 67, I'm going to do each one of these, and then I'm going to evaluate some of the values here, and then I'll go ahead and do 73. So f plus g of x is simply 3x plus 4 plus 2x minus 3, which is 5x plus 1. So I just combine like terms, right? So f minus g of x is going to be 3x plus 4 minus, I'm going to put this in parentheses because I'm going to distribute the negative. And so this will be 3x plus 4 minus 2x plus 3, which is going to be 3x minus 2x is x, and then 4 plus 3 is 7. Now the next one, f times g of x, it's going to be 3x plus 4 times 2x minus 3. So 3x times 2x is going to be 6x squared. 3x times negative 3 is negative 9x. 4 times 2x is 8x, and then 4 times negative 3 is negative 12. So I'm going to combine not like terms, so that's going to be a negative x minus 12. So f times g of x is equal to 6x squared minus x minus 12. And then the last one is going to be the division of, right? F divided by g of x, which is 3x plus 4 over 2x minus 3, and then that's it. You can't do anything else there. Now, I'm going to go ahead and do the f plus g of 3. So now, since I know that f plus g of x is equal to 5x plus 1, I can use that result. There's no reason for me to go back and do anything else. So this is going to be 15 plus 1, which is 16. So f plus g of 3 is equal to 16. The next one I can do f times g of 2. So you can see how that works. So f times g is 6x squared minus x minus 2. So this is going to be 6 times 2 squared minus 2 minus 12. So 2 to the second power is going to be 4. right? 6 times 4 is 24. That's going to be 22 minus 12, which is going to be 10. And that's how you just plug in those. I didn't do all of them for the sake of space, but you can see basically the gist of how to do those. And so 68 is going to be extra for you guys. I'm going to go ahead and jump over to 73. And then 74 would be extra for you guys. I'm going to put it up here just in case I need more space towards the bottom. So the first one I'm going to do is I'm going to do f plus g of x, which is 1 plus, right? So it's 1 plus 1 over x plus 1 over x, which is just equal to 1 plus 2 over x. So the next thing is I'm going to do f plus g of 3, which is 1 plus 2 over 3. So 1, I can write 1 as 3 over 3, which is the same thing, right? Because I need the same denominator. So then this is just b 5/3. So the next one is going to be f minus g of x, which is going to be 1 plus 1 over x minus 1 over x, which is just 1. And so if I were to do f minus g, I believe it's 2. No, 4, sorry. It's just going to be equal to 1 because it's a constant. The next one is going to be f times g of x, which is 1 times 1 over x times 1 over x, which is equal to 1 over x plus 1 over x squared. Now, if I were to do f times g of 2, then it'll be 1 over 2 plus 1 over 2 squared, which is 1/2 plus 1/4. Now 1/2, if I were to, I need a denominator of 4, I just multiply top and bottom by 2, and I get 3/4. So the next one is f divided by g of x. So that's 1 plus 1 over x over 1 over x. So this is the same as saying it's going to be 1 plus 1 over x times the reciprocal, which is x over 1. So it's going to be x plus 1 times x is x. X times 1 is x. So it's going to be x over x, which is x plus 1. And so for this one, it's going to be 1. So then f over g of 1 is just 1 plus 1, which is 2. And that's how you do number 73 for the different combinations. And that's the end of 3.1. Thank you.